Hello everyone, hi, welcome back to the afternoon, the last afternoon, sadly, so quickly it goes, of Clayfest. So sadly Roisin's fallen ill, but I'll just tell you a bit what we're going to do today. We're going to hear three very different speakers, one of which is recorded and Roisin. And she's had a wealth of experience to share with us. Particularly, she first studied architecture and then she spent some time in public services. She also got quite far in backstage theatre and ran a freelance indexing business before she did what she did and maybe during. She loves to volunteer, and she's also the coordinator of the Community Supported Agriculture Network of Ireland. But now she's going to share her experience with using digital tech to survey wobbly buildings, which is not usually two things you put together. But I think Morgan is going to share a nice video from her.
Yeah.
Ms. Roisin and Coil, and I'm really sorry that we can't all be together in person this year. I'm particularly sorry that I've had to pre-record this session due to my health not being great at the moment. My talk is about wobbly buildings and digital surveying. My background here is a photograph of me last year on my way to Clayfest in Wales. We stopped off in the beautiful landscape. I have a background in architecture, and I'm now working in building surveying. I work for Murphy Surveys, recently rebranded as Murphy Geospatial. So we send vans and surveyors and tripods and equipment like total stations and 3D laser scanners around the UK and Ireland and further afield. In this presentation, I will cover what is a wobbly building, my definition of that for the purposes of this survey, what is digital measurement. Then I will show a 3D walkthrough of the interior of a historic building and a condition survey that I did using that same 3D virtual walkthrough software. And I will show a point cloud survey, which is an example of a barn I received from Sarah Roberts with thanks. And just to finish up, the limitations of digital surveying and my belief in the benefits of sketching. In the context of this presentation, what is a wobbly building? When I told my uncle, he said it was a building that moves. And that's not quite what I intended when I set out to talk about these. My definition is the kind of buildings we're familiar with as Clayfesters, maybe buildings built from earth, built from hand, that don't completely have straight lines, that have curves and alcoves and are a bit wobbly, or older buildings such as this one where the timber is sagging or the building doesn't have a straight vertical line. They're a little bit wobbly. So with this wobbly building, and I'm calling this a wobbly building maybe because it's from earth, because the windows are at various heights, they're not straight. Would this wobbly earth building benefit from digital surveying? And I think this would be a good example of a building that would benefit from a digital measured survey, because of window heights, window shapes. Yeah, it's a little bit quirky. I think this would be tough to survey by hand. So digital measuring equipment would typically be this total station with based on trigonometry and 3 points and the little computer doing all the calculations. So placing a tripod with a prism, this prism here, above a nail or a control point, a known point, possibly capturing that known point also with a GPS location device, and then recording points in the logger by noting that the laser or is pointing, or the viewfinder is pointing at maybe the top of a tree, or a window corners, 4 window corners, or edge of path, whatever is being recorded and tagged and logged to be measured. And these reflector targets can be placed on the elevations of buildings, again as a known point or as a control point. And for those buildings that are wobbling in my uncle's definition, as in moving, to carry out the survey again at a later date using those same control points would show that the measurement of the building has varied since the previous measurement, and would show that movement has occurred. This is an example of a measured survey that was carried out of a very small cottage. I think it's really useful to be able to capture the thickness of walls, the walls that are not at right angles, the walls that you might assume are running straight, but actually it stops short of the line of the walls in the adjoining rooms. Similar here. It can capture ceiling heights, floor to ceiling, sill heights, door heights. There's a lot of information captured here and presented. The Matterport camera is a 3D camera. This is it down here, this black box with 9 separate cameras, 3 facing upwards, 3 facing downwards, and 3 going straight across. It sits on a tripod and spins 360 degrees, and each scan or spin is recorded on an iPad. Then that gets uploaded to the Matterport cloud. It gets processed and spit back out as the walkthrough model. So this is a project that we did for the Royal Hospital Kilmainham in Dublin, Ireland, and they are hosting our 3D walkthrough on their website. So it's a digital record of the interior space. So it's possible to pan around to take a look at the detail of the building, to move between spaces. And this can be used as an archival record. However, it's hosted, this particular one is using the Matterport software and hardware, and it's hosted on the Matterport server. So we can't download this digital walkthrough. We have to maintain a subscription with Matterport in order for us and for the Royal Hospital to be able to see it. There's a dollhouse view where we can rotate or look around it. And then there's a floor plan where we can see the full extent of the room surveyed, and we can hop into a particular space if that's what we want to see. It's useful for, I think, short term, possibly while a design is underway, while you maintain the subscription with the server, and that you can have a record of details that you mightn't have picked up during the site survey, for example, where sockets are located, are there fire extinguishers, are there light fittings, doors, a count of things. It can be useful back in the office to maintain a record of that. This is another Matterport survey which I carried out using the 3D camera. It's a very derelict building. The clients were a public sector body, and obviously not many of them visit the building. So it was useful for people sitting at their desks in offices to be able to see the condition of the building without having to go there. I mean, it's actually environmentally quite an unsafe building. Many dead pigeons, fouling all around. So I, just to show you in the floor plan, I was able to label the rooms with different names to cross-reference room A, room B, main hall, to cross-reference with the condition report, which I wrote up. But I was also able to note the condition onto the image. So for example, this one, I noted damp penetration, dampness on the wall dividing room A from the main hall due to defective box guttering at roof level. And this 3D walkthrough isn't showing that box guttering, it's only an internal view, but because I carried out the overall survey from the outside, I'm confident in making that comment. So, bricked up doorway. So just comments for the client to smashed windows to better be able to understand the building as they're walking through this 3D walkthrough. Bird fouling and damp staining, dampness due to defects in roof and skylines. The timber floor in the gym was bird fouling, was quite damaged and dangerous to walk on in places. The two that I've shown are both ground floor, but it is possible to do multi-story surveys using this Matterport camera, and it does show them so that they sit on top of one another. And then there is the option to take measurements. So for example, it's approximately 18 foot from floor to ceiling. Next, I'm going to talk about point cloud 3D laser capture. And when I was preparing for this talk, I mentioned this to Sarah Roberts, and I'm very grateful for her to sending me this example of a project that she worked on. So I've never seen this building in person, but here's a photograph. It's a barn. Sarah sent me some DWG files, which typically people use AutoCAD to use. I'm actually using LineSight, so I was pleased to see that it could open in LineSight. So it enables, I don't know actually if there's a control network in this used for this scan, or if it's in a local grid or a national grid. In Murphy's, we usually, in Ireland anyway, we use the ITM coordinate grid system. And I'm not familiar enough with LineSight to know where those, well, there's a grid reference down there maybe. Sorry, I don't know. So this is the massing of the buildings on the site, the barn and the adjoining buildings, the spaces between them. We can also view this 3D model in wireframe and see the insides, see through them. So a laser scan is similar to the total station measurement, except instead of taking one point, the tripod spins around and takes all the points, pings off any surface that it can see, and then all those points, that the cloud of points has to be processed in an office. So sometimes if a string of points are noticeably in a plane, or if a plane of points are noticeably in a plane, it will generate that wall, or it will generate the truss, the timber. So some of it is artificial intelligence, and then some of it needs a human eye or a human processor. The point cloud information can then be exported into drawings that we'd be familiar enough with on CAD. For example, a floor plan. And this is the kind of thing that I think has really usefully been picked up by the laser scan, that these walls are not straight. There's 3 or 4 kinks in that particular wall, and also that it's not parallel to this one. also that this wall, I think if I had surveyed this in person on site, this wall probably would have been straight. Whereas again, there's a kink to it there. They're not. This building is not completely straight compared to this one, continuous compared to this one. Also, this is not a right angle. The spaces between these buildings, and it's quite a large building, of course, too. The process, the survey will also, the surveyor will, or the processor from the survey might add additional information in text format, such as door height is 0.85 meters, or floor to ceiling height 1.27 seems a little low, but possibly. Or sorry, yeah, and sill height is 0.55. So just to be aware of those little codes and the extra information it's providing. This is the roof plan that's been generated from the point cloud data, and we can see all these rafters that are missing or that are misshapen. Great detail. And in close up, these timber joists and the not straight walls. I don't know what scale this survey was scanned at, but it is important that that you don't design to a scale different to the scale at which the survey. I mean, if you survey at a scale of 1:100, if the survey is carried out at a scale of 1:100, you shouldn't be designing 1:50 based on that survey information. But it is okay if the survey is carried out at a scale of 1:20, 1:50. It is okay to design at 1:200 or 1:500 based on that. So you can design, I can't remember the words, greater or lesser scale. You can, your survey detail must be captured at a small scale. I think that's the word. So 1:20 or 1:50, 1:100, and be careful that that's appropriate to the scale at which you intend to design from the data that has been captured. That's quite a technical point, but I'm sure it'll make sense to one or two people at least. In section, this section drawing just captures all of the rafters and roof timbers just overlaid on top of one another, being piled on top of one another. Whereas so I think it's interesting that we can see the different angles at which they were constructed. If you would like to check out some other forms of digital surveying that Murphy Geospatial have carried out, our projects page has some really interesting case studies in it. You can filter them by different services. And this is an interesting one I found, subsurface investigation, a ground penetrating radar that was carried out on a chimney flue in London. So I leave that to yourselves to discover if you're interested. I don't want to give the impression that digital surveying can replace sketching a building and surveying a building by hand, but sometimes our sketches might turn out wobblier than the building itself, which is no harm. And sitting with a building and taking notes and observing it is very important. And it's with thanks to Carl O'Mahony, a friend of mine and an architect here in Ireland, that I really discovered this. He has been working on a castle in County Kerry, I think, and he's been doing an incredible amount of sitting with the building and surveying and observing. And he sent me through a batch of excellent sketches and drawings that he created from those sketches, where his sketch drawings capture some measurements, capture notes, pebbled render, capture window locations, and even details. And there's a close-up of that detail sketch that he did of this ring, this metal ring and hook, which he observed. Thank you. And as I said at the start, I'm sorry not to have been with you. My email is here if anybody wants to reach out.